Hi everybody. We're solving statics problems. Our topic, three-dimensional force systems. Our question, find the magnitude of the projection of force FAB onto the AC cable in the figure. Yes, we're asked to find the projection of the 560 newtons force AB onto the AC cable. We can do this projection in two ways. We can do it using dot product, or by finding the angle between them, or by finding the cosine of the angle between them and multiplying it by it. We'll do it both ways. First, let's solve this problem using dot product. Which vectors will we be scalar multiplying? We'll be scalar multiplying the force vector by the unit vector along the direction we'll be projecting. Let's call it E. Let's call the unit vector on the AC cable E. Let's call the unit vector E. Now, let's first write these vectors in terms of I, J, and K. To find dot product, let's first write the force AB in terms of unit vectors. Let's write it in terms of I, J, and K. Next, let's write the unit vector E in terms of I, J, and K. Let U be the unit vector in the same direction as AB. We know that a vector can be expressed as the product of its magnitude and the unit vector in its own direction. Therefore, FAB equals the magnitude of FAB times the unit vector U in its own direction. Similarly, we can write the position vector AB. The position vector AB equals the length of AB times the unit vector U in its own direction. Since both vectors are in the same direction, their unit vectors are the same. The unit vector for both is U. If we subtract U from the relation below and substitute it into the relation above, the vector FAB equals the magnitude of FAB times the ratio of the magnitude of vector AB to its magnitude. We have obtained this relation. We will use this relation frequently. We will use it in this problem too. Let's use it. Yes, we will write the vector AB in terms of I, J, and K. We are moving from A to B. We can write the vector AB by looking at how far and in what direction we move parallel to the axis as we go from A to B. This is the practical way. But you can also write it by subtracting the coordinates of the starting point from the coordinates of the end point. It is also possible to write the vector AB that way. Going from A to B, I first moved 3 units in the negative direction parallel to Y, then 1 unit in the positive direction parallel to Z, and finally, 1.5 meters in the negative direction parallel to X. The coefficient of I is minus 1.5. The coefficient of J is minus 3, and the coefficient of K is 1. In other words, the vector AB is minus 1.5 I minus 3J plus K meters. We find the magnitude of AB from the Pythagorean formula and substitute it in. We know the magnitude of the force is 560 newtons. We substitute that in, and thus we obtain the force vector in terms of unit vectors. FAB equals minus 240I, minus 480J, plus 160K newtons. Now it's time to write the unit vector E. The unit vector E is the unit vector in the same direction as the vector AC. Let's write this unit vector in terms of I, J, and K. To write this unit vector in terms of I, J, and K, we can write it by dividing the AC position vector by its magnitude. So, now we need to write the AC position vector. We'll go from A to C. As I went from A to C, I first traveled 1.5 meters parallel to X in the positive direction, then 3 meters parallel to Y in the negative direction, and then 3 meters parallel to Z in the positive direction. So, the coefficient of I is 1.5, the coefficient of J is minus 3, and the coefficient of K is 3 meters. Thus, we obtain the AC vector, 1.5 I minus 3J plus 3K. We substitute it in. We can also find its magnitude using the Pythagorean formula. We substitute it in below, and thus we obtain the E vector in terms of I, j, and k. The E vector is 1/3 times I, minus 2/3 times j, plus 2/3 times k. We will perform the dot product of these vectors. Let's write them down and expand the parentheses. Both have 3 terms. There are 3 terms, I, j, and k. 3 times 3, we get 9 terms. But we know that 6 of these 9 terms are 0. Only 3 terms are non-zero. They come from the product of I and I, j and j, k and k. We obtain minus 240 times 1 from the product of terms that include I, minus 480 times minus 2 from the product of terms that include j, and 160 times 2 from product of terms that include k. The coefficient of 1/3 is already on the sidelines. That's there too. Let it wait there. Yes. So, we found the magnitude of the projection of the force AB to the AC line. The result we get from here is 346.7 newtons. Now let's do it geometrically. Let's find the cosine of theta. Let's find the projection by multiplying the force AB by cosine theta. Let's obtain the projection. We can find cosine theta using the cosine theorem. Yes, we can find cosine theta from here. Let's write the cosine theorem. The side opposite the angle theta is side BC. We write BC first. BC squared is equal to AB squared plus AC squared minus 2AB AC cosine theta. To find cosine theta using the cosine theorem, we need to know the sides of triangle ABC. First, let's find the sides. We find the sides using the Pythagorean theorem. We find them using the given geometry. Side AB is 1½ squared plus 3 squared plus 1 squared, the square root of the sum of their squares. AC is found similarly. BC is found similarly. Since points B and C are in the XZ plane, there's no third component. But the other 2 sides don't coincide with the Cartesian coordinate planes. Only side BC does. Therefore, the others have 3 components. BC only has 2 components. From here, we calculate cosine theta. Cosine theta equals 0.619. We substitute this in. We find the projection of the force FAB onto the AC cable. We get the same result, 346.7 newtons. Goodbye.